Hi, this is Alex Designman and welcome to part 2 of this automotive main cabin harness with Catia V5 electrical harness design. So if you just click on this and you don't know what's going on here, you need to go back to part 1. You need to find part 1 on my YouTube channel and watch that from the beginning. So going forward here, I'm going to route the bundles from this grommet to those two connectors. Branchable. But first, I need to add a point on this grommet. So grommets can be electrified or not, depends on the type of grommet, how it was designed, where are you using it. Point, have here an axis, can use for tangency. Go straight into this connector. Let's make this 10 millimeters. So here I'm going to have a portion of around 20 millimeters of bundle that is probably going to be tape. In fact, let's make it smaller. Let's make it 15. This depends a lot. This is a discussion that if you work in a company, it should be taken with the manufacturing plant. So then let's add another bundle from this point to this connector. So I'm going to add later slack. Now let's just go forward with the main bundle. So exactly like we did here, I'm going to add a sketch from part design. Make this 15. Take a line here, point in between. Okay, and here let's add around 3 millimeters. Line, construction element, point, standard element. Okay, perfect. So now this is 15 millimeters. So from here, from the plastic channel, we go to this retainer, forward to this retainer, and here we have the next plastic channel. I will do the same thing here. So because I'm here, I'm going to also make this other sketch, so I don't have to go to part design again. So obviously we're going to have also a sketch in here. Okay, so let's continue here. Strap-on stud, adapter, here. Okay. And then from here, continue forward. And finish it here like we did on the other side. I'm also going to do this here very quick. Add after. So I'm going to add a point here and one here. This is fine for now. So again, if you want to see more details about why I do what I do around here, those are in the course in Udemy. can find links at the video description and everywhere on my YouTube channel. So in this YouTube channel is basically, I made this to present what I do on Udemy and my services, my personal services. So this is not like an influencer type channel. And I also started to give some tips, some knowledge, because a lot of people, they ask me, so I have thousands of messages on LinkedIn. So I have over 20,000 students on Udemy, get messages on Udemy and also on LinkedIn. So in here, first let's add Slack everywhere. So I'm going to add some Slack here. Let's see, 3, okay. So like on the other side, this one needs to stick to the body and white surface. Let's add some Slack around here. This is kind of the same, so it needs to stick to the body and white surface. Come as smooth as possible, because there is a carpet here. And here we arrive at the end. So now let's do this branch here. So here we did the sketch, but in case you get any type of error in this bundle, when you try to do Slack, for example, it might not accept the sketch. So there are Catia v5 versions that do not accept any type of things, so they might give you an error. The more advanced Catia v5 versions are going to allow you to do a lot of things. So in here, I'm just going to add a point. So I'm going to add that on a plane. Just add a point here. So the plane is going to be this surface. And just add the point here in this area. But I want to add it in the middle. So reference, let's pick a point around here. And then this is our point. So to make this right in the center, I'm going to measure from here to here. So this is 12. This coordinate is 12, and then from here to here. So from here to here, this is 18.71. I just want to leave 2 millimeters here, maybe 3. So let's leave 2.71. So I want to make 16 from here. So this quote is going to be 12, but this one is going to be 16 minus 7.5, 8.5, minus 8.5. This is a simple calculation. So you just have a point. You can do, if you know Catia v5 part design, you can do many stuff here just to add points and not add a sketch, because it looks like the sketch it's a problem. In case the sketch gives you errors. And let's end up in this connector. So this cable is kind of thick. Let's make it 12. So 12 should be okay. Let's add some slack. So I'm going to try here a little more than that. Okay. Branch point. Reference from here. Length 50. How much is this? And from here, This one is going to be smaller from the branch point to the connector. Also, the length of a branch, you see this is 51 from the connector to here. So there are requirements with the minimum length. You cannot have like the 10mm branch, for example. That's not possible to manufacture in reality. So there are minimum lengths, and of course you need to find solutions if you don't meet that requirement. Let's make this one around 9, and this one has to be smaller. Let's make it 10. So on this branch here, I would like to add a little more slack. Let's make around 5. And from here we're going to have a branching point that is going to go to those connectors. So let's add in this area here, and after that see how it looks. Reference, let's choose a point here. Try 50. We are going to play with it if it doesn't work. So those wires, let's try 7. So this is a typical issue in electrical harness design. You see, when you design branches coming out of a bigger branch, they're going to have a branching point, but you see that, for example, this one is just clashing with the main bundle until it gets to the branching point. So in reality, this is not real, it's not going to happen. In reality, it's just going to go around it until it gets to the branching point, and the next one is going to go around it, and this one. So they're not going to look like this in reality. They are going to look different. Maybe they will go up. So you need to take all of those in consideration, to think about them, to record this issue and see if there is anything around that those can clash to. So you cannot just leave them like this and hope it's going to go well, because in reality this is where the issues appear. Something doesn't fit, or you might have a retainer like this one, which is pretty small, and it might be pulled out of the hole because of the tension in this area. There might be a problem with the line operator assembling those connectors. So you need to be careful about all of those when you do a harness like this. If you do those from scratch, for example, if you have this plastic part done from scratch, I would immediately tell the mechanical designer who designs this to make this part here longer, so I can have all the space in between a main bundle and connectors. So this is what makes the difference between a very good harness design engineer that gets paid 40, 45, 50 pounds per hour, and someone that cannot get the job. It's those details. So it's not Catia V5, it's not the tools, it's not electrical diagrams and all that stuff. So those things, they already exist. Wherever you go in a company, everything is there already. What they need, it's a designer, a design engineer that can pay attention to those details that do not appear in CAD. They appear in reality. So in CAD, everything looks perfect. In reality, you get problems. So here we need to design the branch that connects to the fuse box. Branch that comes out of the fuse box. So it's going to be around here. Going to add a branch point in this area. We also need a point here. And let's add some slack. So this issue here is solved with slack. Bend radius is 24, very close to the limit. So that's fine, as long as it's not red, it's okay. And from the same branching point, if that's permitted in the rules of manufacturing, we add a branching point that goes to the door connector. So here we have 1, 2, 3, 4 branches on a branching point. So in manufacturing there are limits to how many branches you might have in one point. So again, this is something that I discuss in the courses, and more exactly I discuss about this in the electrical harness, high voltage harness for electrical vehicles and batteries, because there I have a few instances where we need to have a lot of branches in one point. Now let's design this branch here. Start from here, this retainer, and the last connector. So this is actually a situation that I had in quite a few vehicles, where you have two retainers so close to each other, and you also need to have branches for all the connectors that are very close to each other. This brings a lot of issues in manufacturing of the harness. So this needs to be a pretty good discussion with the manufacturing plant. So I'm not going to go into those details. I discuss those details in the courses. In here, I'm just going to design those bundles like this. This is going to be smaller. Also this one here. So all the length we can add in a situation like this, it's very good, because it's shortness, the problem here. Very short branches, many times they are difficult to manufacture. And in fact, they're not going to be like this in reality. They are going to be different, but they cannot be designed in Catia. So there are other calculations and things that we need to measure around here to make sure that this works in reality. And I show that in the courses, of course. And another one here. So this is also an issue, to add a branching point between two retainers that are so close to each other. So all those issues are solvable when they're taken step by step. Most important thing is to actually realize that there is an issue, because it's very bad when you don't realize and then you see it in the assembly line, and that's when you get to the assembly line, it's too late to change this bracket, for example. So this bracket is going to be in mass production tooling. There is no way they are going to modify it for your wires. You're going to have to deal with your issue, because it might cost $50,000 to modify a bracket like this one, to modify the tooling. So they're not going to do it. So you're going to have to do a bad harness that doesn't respect the requirements, and that can bring you issues. If you got issues to the connectors, to the pins, the assembly line. So if the operators on the assembly line, they have issues here, they cannot mount these connectors or something like that. That's very bad. That can cost you your job if you don't take everything in consideration. And the most important thing is you have to realize, just make a measurement from like here to here. So this is 62 millimeters, and now you take a ruler and realize how it's 62 millimeters in reality, and imagine that an operator needs to put his hand here, his fingers, to push in those connectors and the clips and everything around here. So when you do it like that, you are going to think differently, and I'm going to give you a tip. If you put those connectors on, you cannot mount those clips anymore, because you don't have enough length in the harness to mount them. If you mount those clips on, then yes, we can mount the connectors, but you're going to be enclosed in this 62mm space with the fingers and the connectors. So this is something that have to be taught in advance, and you can even ask a manufacturing plant to do a simulation. So they will put something that simulates this entertainment unit and a piece of harness and something that simulates the bracket. Maybe they can do it 3D printed. They can do a lot of that stuff today. If not, they're just going to fix the retainers here at this distance and see if someone with a bigger hand or a smaller hand can mount those connectors and how hard is it. So this is a very big issue in reality, because who really leads the design is the manufacturing department. So those guys, they work on they are on the assembly line, and if operator gets pain in his fingers every time he has to mount your connectors, you're going to need to modify the design, because that not works on long term. So the mass production, the production of the real vehicle, is actually more important than everything the design engineers do. So that's the most important thing, the vehicle, how fast they can mount the vehicle, because that brings money in the company. Here we have the other half of the harness finished. We have everything ready for this harness. So I'm going to use this to create a drawings, and we are going to do that in a future video. The only thing left here that I have to design is going to be to add the connector here in position for the door, and to add the branch that goes up to this connector, and the same for this other side here. So I'm not going to do this in the video anymore, because I don't want to make this video any longer. And it's just some simple design here. It's already made. We have the retainers in position. The connector is going to be similar with this one, and another one is going to be the branch that goes to the connector for this seat here. And we have here two holes in the bracket. Have to put two retainers and create a branch from here and arrive like we did here to this connector. So also I'm going to have to mount the counterpart in here. And another thing here, it can be to add a retainer here and just design those two wires that go from those two connectors in the retainer. So what can that be? Those are inline connectors where some other harness connects to the main cabin harness. So this is the main cabin harness. Inline connectors, this is a new harness that goes beyond the inline connectors. And more exactly in this area, you might have the console harness. So if you have a console here with some buttons and some lights or whatever a vehicle might have around here. So I worked a lot with luxury vehicles and they have a lot of stuff inside. Then we have the inline connectors for the engine compartment harness that they go through the grommet. So depending on the design, this grommet, those inline connectors, they can be on this side or they can be on this other side, and you have a piece of harness that goes through the grommet and the inline connectors here. So when you mount them, you need to pass the connectors to this huge hole in here, and after that you mount the grommet, and the connectors are mounted on this side and they connect to the engine compartment harness. But I also seen this compromise where they did it the other way around, because they wanted this, they didn't have space for the connectors here, so they wanted to add those connectors here on the inside. Also because on this side, this is a wet area, underbody, engine compartment needs special connectors, so I explained that in the courses. You need high temperature connectors for that are heavy duty, and they have seals and special pins and everything, so they're more expensive. In this area here, you do not need that, so this is a dry area. That's why we have a grommet, so the wet stuff and the dirt does not come inside here. So this is the harness. I'm going to complete those other branches in the background. I'm going to save here. If you want to do this project and practice it, so this is to practice, because this is how you learn. You watch the videos from the course, you take notes with all the explanations that I do there, and you design the harness. So this is how you remember them, this is how you become good at it. And I've seen from the best students that I have in the courses, so from each part where I stay and I explain things, why do we have two of those here holes, why do we do this, why do we do that everywhere. So they just take a screenshot. So they do it, they do the harness, they take 1 or 2 screenshots, how many they need. They add notes here with all the explanations that I say, and all the tips and everything that they want to add, and they put that in a document like a PowerPoint presentation, and they just save it there, and then they go to the next part, and to the next part they take another screenshot, they go here, they take another screenshot and another one and another one. So they write everything that I explain around here. So they do that because they can just watch that PowerPoint presentation. And also, if you do a presentation like that, if you take notes, it's easier for the brain to remember all of those things. So it's also a different kind of exercise. And they can just spend 30 minutes or 1 hour to watch all of those screenshots from the presentation. So they can do that once a week for a few weeks, and then you'll just memorize everything, all of those informations that when you're at a job and you design, they will immediately come to your mind, because you're going to see that issue or that solution for a problem. And of course, if at an interview they ask you something and you say a few of those things that I teach in the courses, they're just going to realize that you actually have experience, even if probably you don't have it in your CV. So they will have no reason to not hire you. That's why I did those projects in the courses. It was the only way to make students practice and understand. So making PowerPoint presentations and just showing that, I have a lot of videos with information like that, but actually doing the work in 3D, that's the best way to make someone understand. So this is the end of this project, and in a future video we are going to do drawings with this harness. So it's the type of drawing that you'll have to do to send to the manufacturing plant. And I'm going to show you quite a few ways to do that, and also how do we do modifications or engineering change requests. Every company has a system like that. So I'm also going to show something like this, which is pretty easy and systematic. So until then, I hope you enjoyed this, and see you in the future video.